Hello and welcome to today's class. We're looking at how to solve this question here using the idea of Kirchhoff's law. So the question says calculate the current and power developed in each resistor as shown above. So we're trying to calculate the current um, in the resistor as shown above. By the way, the value here is before 24 volts. All right, so I have this man here. So we're actually applying the idea of Kirchhoff's law. So from Kirchhoff's law, there are two laws, as we said last class. We have the KCL, which signifies the Kirchhoff's current law, and we have the KVL, which means Kirchhoff's voltage law. We're applying these two laws in solving this problem. So my first task here is to apply my first law. So using the first law, solution, apply my first law, which is known as the KCL, that's Kirchhoff current law, right? So law 1, apply law 1. Law 1, what do we know from law 1? Law 1 says that KCL, that's Kirchhoff's current law, says that the sum of currents flowing inward must be equal to sum of currents flowing outwards. So I'm saying that summation, that is, we say summation V equal to 0. So it means that I'll have that summation I. So I have assumption I in is must because of what the assumption what I out. This idea was from KCL, that's Kirchhoff's current law. This idea was brought up. If this is true, check a diagram. Which are the currents flowing in and outwards? Observe that I1 is flowing in, I3 is flowing out, I2 is flowing out. It means that summation I in, the only in was I1, so I have I1 equal to this outer are 2, I3, I2. That becomes I2 plus I3. Alright, call this man equation 1. I have applied my first law, which is called the KCL, Kirchhoff's current law. Let's apply law 2. Law 2. Alright, for your law 2 is called the KVL. The law 2 is called the KVL, that's Kirchhoff's voltage law. And for Kirchhoff's voltage law, we also said it's also called what, the loop, right? So for this one here, let's apply the second law called Kirchhoff's voltage law. For this one here, please note, we said it's also called a loop, right? So I have two loops here, or let me call it match if I want to. Let me call here A, let me call here B. All right, call here A, call here, because I have two sections here. So call this one A, call this one B. All right, my next task now is that I'll look for the match. So I'll look for loop at match. I will apply second law at section A and at section 2. So the task there is that, so for loop A, I'll focus on this place. For loop A, also called match, I can also call it match. For loop A, I mean this loop A, also called match if I want to. Why match? Because I can't find other loops in it. So for loop A, this A now, here's the idea. We said summation V equal to VA equal to 0. That's low there. Summation V equal to 0. From when I gave you the idea behind KVL, that's Kirchhoff's voltage law. So I have that summation VA, because I'm using A here, summation VA equal to 0. If this is true, I'm adding all the voltages. That's meaning and I'm equating that to what? To 0. Now, this is my first voltage here. Abi? Now, consider this first voltage here. This voltage is moving from a lower to higher. So when a voltage, or sorry, when a current, because this is, I'm moving this way now. I'm following the given direction, the assumed direction. So moving this way now means I move from what? A lower to higher. If I move from a lower to higher, what's voltage? Would this be positive 24 or negative 24? Positive 24. So I have 24 24 as positive. Why? Because this man here is moved from what? A lower to higher. And I said when current move from lower to higher, the idea there is that it will be positive. So I have a positive value here. So it means the voltage here is what? Is positive. I'm done with this. Move on to this part here. This one here is the resistor. And I said this one summation V means I'm adding all voltage together. At this point now, I'm having a resistor. It's easy for me to convert resistor to voltage. How? Just multiply that resistor by I, that's all. So I times R gives you V. The voltage from Ohm's law says V equal to IR. If I have resistor, I can convert it to voltage. How? Multiply I with it, that's all. So from here now look up please, from here. So this direction now, observe this direction. This one here moves this way. So if I want to pass here, I'm moving from lesser to higher. I have a positive 24. Come in. Just sit down. Just sit back. Wait on here. Yeah, wait on. Just sit somewhere. Just anyway. So I'm saying that. So this part here, this one, follow direction. I'm moving this way, negative to positive region. That I have a positive 24 because said when current move from lower to higher, use positive. Next task here is this man still move this way. So moving this way, the direction of the current is this way. So when the assumed direction follows the original direction for the current, we say use negative in that case. That becomes negative. Negative what? We said convert this one to voltage. How? R1 times I1. This gives you R1 times I1. That's all. So this man is my voltage in this case. Still proceed. This one here, because I'm moving from positive to negative. This man move this way. Current move this way. Positive to negative. If this one move this way, it follows the direction of this voltage, of this current here. So if the direction are the same, you say use what? Negative. I multiply your R by I. So I have this one here. I'm still on section A. Moving this way too, my current is moving this way. That's positive to what? Negative. I'm moving this way, follows the same direction pattern, become negative. So if direction are the same, use negative. So I'm moving negative. What's the R and I there? R2, I2. So I have R2, I2. This man is equal to 0. So say assumption A equals to 0. So this man, because there's no more other resistor here aside 1, 2, 3. That's all. Voltage, resistor convert voltage, resistor to voltage. So I have this one here. Put in your value. This gives you 24 minus what's R1? So R1 is of course 3 ohms. So I have 3I1 minus what's R2? That's a 4. So I have 4I2. This man equal to 0. Make this man well expressed. Here's the idea to save time and space. If I take this one here, become positive, Abi. Here too positive, Abi. And here becomes positive on its own. So it means that if I will have 3I1 plus what? 4I2. What was there? 24. Call this man equation 2. I have equation 1 here, equation 2. This is for loop A. That's this. Let's work on loop B and let's see the equation we will have. We'll now combine the 3 equations together and solve it simultaneously and get the value of I for this man here. And then we'll look at the power developed in each resistor as shown above. All right. So from here, I'll take off this part here. So at this point here, so for loop A, that's all here. Let's go for loop B. So for loop B, also called match, if I want to, and I explain why it's also match. I have this place. For loop B, this is my loop B. No problem. Bear in mind, current move from positive to negative here in this case. For my loop B, I just have two. That's R2 and R3. That's all. Now, observe this movement, please. This assumed direction is opposing the original direction of the current. Always what? Positive. If the direction of the current, if the given or assumed direction is going opposite to the direction of current, take it as what? As positive. You said that. But if they are going in the same pattern, that's negative. So my first task says that summation VB equal to 0. This man move this way. That becomes positive what? R2 I2. That's I2 R2 or R2 I2 if I want to. So this one move this way. So move this way. I'm moving from lower to positive. That gives positive because it's the opposite direction of the current. I have this one here. Now I've passed through this part. Remember this one here. I'm moving this way. Moving this way here follows the current direction here. Right? I'll use negative in that case. Negative what? I3 R3. So R3 I3. Let's put R first. R2 I2. I have the space equal to 0 because I just have 1, 2. That's all. From here on this from here, this gives you from here R2 is of course 4. That's I'll have 4 I2 minus R3 is 12. 12 I3 equal to 0. Right? So here's tax. Here's the tax. Here's the idea. From this place now, my equation 3 becomes 4I2 minus 12I3 equal to 0. Call this man equation 3. Alright, I have equation 1, 2, and 3. Let's bring those equations together and solve them simultaneously. And let's see what we get as the result. Alright, these are my equation 1, 2, and 3. Let's get I1, I2, I3. Alright, what do I start with here? What's my first task? Obviously, it's easier for me to start from equation 3 from here. So let's just say this list. From equation 3, what do I have there? I have 4I2 minus 12I3 equal to 0. Take this man here. I have 4I2 equal to 12I3. Divided by 4. Divided by 4 by 4. This man cancel this. I have that I2 is equal to, here gives you 3. That's 3I3. So bear in mind that I2 is equal to what there? 3I3. So I can call this my equation 4 if I want to. Equation 4. Next task, I'll put equation 4 into equation 1. Right? So put 4 into 1. So put 4 into 1. What do I get there? I1. We said I1 equal to I2 is 3I. Okay. I2 is 3I3. So that's 3I3 plus I3. I have I3. Here gives you I1 equal to I3 is addable. 1 plus 3, that's 4. This gives you 4I3. So note that I1 equal to 4I3. I'll now put I2 and I1 into equation 2 to get I3. That's tax. I'll put I2 and I1. That is, let me call it equation 5. Equation 5. So I'll put 4 and 5 into equation 2. So put 4 and 5 into equation 2. What I have here? This gives you 3I1. That's 3I1. You said is what? 4I3. That's 3 into 4I3 plus 4 into what's I2? So the I2 is what? 3I3. 3I3. This equal to 24. It's clear that for me I can get I3 from here. Let's get I3 please from here. I3 from here. Let's get I3 from there please. This is F. From here please, I3, this is 3 times 4 is 12. That gives you 12I3 plus 12I3 equal to 24. I have this one here. Let's start here. 12I3 plus, they are common, they can add up. That gives you a 24I3 equal to 24. This gives you 24 over 24. This cancel this. Therefore, my I3 equal to 24 over 24. That's 1. That gives you 1 ampere. So I3, for me, I3 equal to 1 ampere. I3 is done. Let's get I2 and I1. But observe, if I got I3 as 1, it means that if I put I3 as 1 here, I can get I2. Right? That's that. And see I1 too. I've gotten I3 as 1. So if I put 1 here, I can get I1 value. So let's get I1 and I2. So I3 is 1. From equation 4, so I'll put I3 as 1, put I3 to be equal to 1 ampere into equation, what's it called? Equation 4. Equation 4. Equation 4 says I2 equal to 3I3. So I2 equal to 3 into what's I3 there? That's 1. So my I2 in this case, so I2 equal to what there? 3 amperes. That's your I2. Let's get I1. How? Record this equation 4, equation 5. So put I3 to be equal to 1 ampere into equation 5. This one says I1 equal to 4I3. All right. From here, I1 equal to 4 into I3 is 1. That's 1. This one gives you I1 equal to what there? 4 ampere. Here is the task. You have to find current at each resistor. So I1 equal to 4 ampere, I2 equal to 3 ampere, and I1 equal to, I3 equal to 1 ampere. These are the current value in each resistor. So I1, this I1 here is 4 ampere, I2 is 3 ampere, and I3 is 1 ampere, as you can see displayed on the board. So we're going to say we should find the currents, which we have done. So let's also find, calculate the power developed at each section, right? So power developed at each section. So I'll take this off. Lesson number 2. Power developed at each section. The power developed at each section. Let's get power developed at each sections. All right. Now listen, please. When it comes to current cycle, what have you? Power is equal to, okay, question B. The power developed, please. The power developed. So power P is equal to what there? IV. That's the I there. Now in this case now, this can be expressed as power equal to I. V is of course ZV equal to what there? IR. So because we are as IR, so V becomes IR. So I have IR. So the part I'm using here, P, will be equal to what there? I times I gives you I squared. So that's I square R. So the formula we're using here is what? Because in this case, I don't have voltage for each of them. I have only R and I. So better use P equal to what there? I squared over R. So at each sections, so at section 1, at section 1, so the power developed at section 1, P1, should be equal to what? I square. So the current at section 1 into what there? R1. The source at section 1. This is equal to I1. What's our I1 that we got there? I1 was 2. What's I1? Check I1. The value for I1, what we did initially. I1 is 4. That gives you 4 all squared into what's R1? R1 is of course 3. This man gives you 16 times 3. The power developed at section 1 will be equal to 48 watts. But why is it in watts? I have this place. At section 2, the power developed, that's P2, equal to I squared 2 R2. What's I2? What's the value of I2? I2 is 3 ampere. That's 3 all squared times what? R2 is of course 4. This gives you 9 times 4. So the power at section 2 gives you 36 watts. Finally, at section 3, the power developed at section 3, all right, at section 3, all right, that's P3 equal to, the format is what? I square R, but in terms of 3, that gives you I square 3 R3. This is now equal to I3 is of course what there? That's 1. There, that's 1. 1 all square into R3 is 12. This man gives you 1 times 12. The power developed at section 3 is equal to what there? 12 watts. Alright. This is how you find the current and the power developed at each section using the idea of Kirchhoff's law as illustrated on the board. If you found this class helpful, do it to like the video, leave a comment, share to your friends and classmates, and subscribe to my YouTube channel. Welcome to Excellent Link Academy. See you guys in the next class.
I just launched a book called The Shortcut to Academic Success. In this book, I share a lot of experience on how I evaluated during my time in school. This method really helped me a lot. If you're interested in getting this book, simply chat me up through my WhatsApp number that is shown in the screen. I just launched my website www.ghanabukari.com, as you can see in the screen. In this website, you can get close to 4 to 5 tutorial courses that are there. So we have different courses there. Also, the book I just launched also is in the website. You can visit our website and get the courses you want to watch. And also, the video you're watching recently, you can get more of these interesting videos in the website. So do well to visit the website and also register an account with my website. See you guys in the website, and make sure you buy a course from the website to support our journey of this academic platform. Thank you guys, and welcome to my channel. Guys, I just launched some courses on my website. These courses include physics tutorial for year 1 student, WAEC/JAMB student, WAEC/JAMB classes for JAMB student, and also I have the organic chemistry for beginners. So these courses, you can get these courses on my website, as you can see displayed at the right hand side of the screen. Alright guys, you can now join my channel membership to have access to exclusive videos of mine, which most people will not have access to. To get this link, membership program, as you can see the left hand side of the screen, you can see the YX/JAMB classes. You can go there. It of course 1,000 naira, or you go for the other level student to have access to both. Right. So once you join the channel membership for other level student, you will have access to both the WAEC and the JAMB classes with the other level itself. So do well to join this membership to support our online academic session. See you guys sooner.